So as I mentioned, we have a really quick activity now, and the point here is to get you thinking about data types and thinking in data types or in terms of data types. So what I'd like you to do is draw or write or just think about a tweets table. So modeling tweets. If you're not familiar with Twitter, that's going to be a tough one, I guess. But basically, there are three things I need you to, at least three things that I want you to model. And these are the columns. So a username. So when someone tweets, let's say I tweet and I don't actually use Twitter, but if I had an account and I called it Coffee Lover Cult, I mean, that's just terrible. But if I did, it would need to be maximum 15 characters long. So how do you specify that? What data type is it? Then the content of the tweet, so whatever the tweet is itself, can't be more than 140 characters. And then the number of people that have favorited that tweet, basically liked it or hearted it. So you don't have to draw it out, but if you want to draw it out in that tabular format and then fill in some fake data or even real tweet data that you find, go ahead and do that. But just think about what these data types are in terms of what we just learned. And there's really only two choices that we saw, so hopefully it's not too difficult. So we'll be right back with a solution. Okay, so let's start talking about the answer. So we had username, which was a maximum of 15 characters. That would be a varchar, and you would put 15 in the parentheses to specify that it's no more than 15 characters. Then we have content of the tweet, max of 140. It's very similar. It's also varchar, it's text, but this time we restrict it at 140 characters. Then we have favorites, which is just a number, so we use int. And then here's some mock data that I added if you want to take a look. We have cool guy who tweeted my first tweet, and that was one person who liked it or favorited it. Then we have guitar queen who tweeted I love music, smiley face, how endearing. And we have 10 favorites on that. And then lonely heart, this sad guy or gal who tweeted still looking for love, and that has 0 favorites because nobody wants to be depressed. All right, so next up, we're going to see how to take these data types and actually tell SQL or MySQL how to implement a table using those data types. Hey there, it's me again. It's time for yet another one of these videos. This time we are diving into section 3, a really important section. And yes, you could probably say that about everything in this course, but this is where we really get going. It's really crucial. In the last section, it's true, we did run our first MySQL commands, but if we're being honest, they're a little bit underwhelming, kind of lame, they didn't do much. In this section, that actually changes. We see our first commands around data. So we'll be able to make a new database or delete a database, and then inside of those databases, we'll start working with tables, which are kind of the fundamental structure in all of SQL and MySQL. So really important stuff. And by the end of the section, actually throughout the entire section are sprinkled a bunch of exercises around commands that we'll learn, things like creating databases, using and switching to databases, and then creating tables and describing tables. So a bunch of challenges coming up. But like I said, this is a really important turning point where we actually get past all the garbage around setting stuff up, installing. Now we're actually doing real MySQL stuff. So let's get going. Okay, so the first thing we have to cover is making databases. We have to have some databases before we can then put stuff anywhere inside of those databases. So it's a couple of steps that we need to go through before we can even really work with real data. But this is a really important piece of using MySQL or really any SQL database. So we've got our database server that's already installed and set up, and within the world of a database server, we can have a bunch of different databases. So these are self-contained sort of silos of information, silos of data, and tables, which we'll learn about shortly. And they have nothing to do with one another. It's important to know that our data isn't all floating around together in one soup, but rather it's divided up into these discrete databases. So we could have a dog walker database, a news site database, just a practice database if you're trying things out, and they're all separate. So let's zoom in on just two, dog walker database and a soap shop database. So we have a dog walking app and a soap e-commerce store, I guess. Both of these will have some data, right, that is unique to them. So we'll have some dog stuff, dog profile, walkers, something like that inside of the dog walker database, and we'll have a soaps set of information in the soap shop database. But they also might both have users. They might both have payments, but we want them to be separate, right? We can't have contamination where all of a sudden we're charging people in the dog walker database when they buy soap or vice versa. We want to have each set of data in its own little bubble. So that's what we call a database. So one more time, we have multiple databases within a MySQL database server. So the first thing we need to do as far as code is take a look at what databases currently exist. When you install MySQL, there will be some default databases. You probably won't need to touch them at all right now. Well, you definitely won't need to right now. But this command, show databases, we've actually seen it briefly when we installed. This will show us those databases. So I'm going to flip between using the terminal and Workbench in this video just to make sure we cover all the bases. The first thing we'll do is fire it up in the terminal. So again, this command is mysql-u, and then I'm logging in as root. That's the only user we have right now. And then I'm going to provide a password afterwards, -p. So I need to provide the root password that I set up. And I hit enter, and if I have the right password, this is what I see. Now I'm going to clear my screen with Control-L just so you don't have to look at all this text. And my prompt has changed to MySQL. So I type stuff in here, and I am in MySQL land. I get an error because that doesn't mean anything to MySQL. But this should, if I do a show databases with a semicolon, if I don't have that semicolon, you'll see that I get this arrow. It's asking me, it's kind of waiting. It's like, okay, and then what? You haven't terminated your command. But a semicolon tells MySQL this is the end. Okay, so what do we see? We get this printout that says, here are the databases you have right now. Information schema, MySQL, performance schema, sys. You really don't need to worry about these. But the fact that we see something tells us databases exist. That's kind of all you need to know. Now, over in the Workbench, to log in, to connect to the database, I have this local instance connection. I have to provide my password here, right? Because the whole point is that we're doing this with a graphical interface, not via the command line. And then what I can do is run this command. I'm just going to type, unfortunately, I can't make this much larger, show databases, semicolon, and I'm going to click that lightning bolt. And I get a result back, and it's the same information, the same data. It's just displayed in this app, right? Information schema, MySQL, performance schema, sys. Same thing here. Just two different ways of accessing that. Now, this is not that exciting at the moment, not at all exciting, because we don't have any new databases, and that's going to change in the next video. So we've been looking at the existing built-in databases. It's not very exciting. Well, this may not be all that exciting either, but this is a step in the right direction. We're going to learn how to create new databases. So these will be an empty database. It's just like an empty bubble that we then will put our database information inside of. But all that it starts out as is an empty shell that has a name. So the way that this works, by the way, the syntax that I've written here, anytime you see this in these slides, these angle brackets mean you replace this with your own name. So you don't actually write those angle brackets. So create database and then pet store or soap store or dog app. Now, in terms of how you name these, you want to come up with something unique. That is obvious. You're not going to be typing this all that much, honestly, compared to the names of the entities inside the databases. But it should be an obvious name that makes sense, right? It should be meaningful. You technically can put spaces, but it can cause problems, so I highly recommend against it. You won't really see anybody put spaces in them, so just don't. But you can use underscores, what we would call snake case, or camel casing, uppercase letters for each word. It doesn't matter. You just want to come up with a name that makes sense. Now, in terms of the capitalization here, this also doesn't actually matter, but this is really common in SQL. We'll see this all over the place. Basically, you capitalize all the SQL keywords like create and database that are always the same, and then that helps it stand out from your content, like the name. So you don't have to. I'll show both, but you probably should, just to make it easier. So I'm going to make a new database. I'll make a couple. Create database. I'm going to do it from the command line first in my MySQL shell. Create database. Let's call this, I don't know, pet shop, just like that. Now, again, I need the semicolon, and if I forget it, that's okay, because my prompt sort of reminds me it's waiting. That's what that arrow means. It doesn't say MySQL. It's just an arrow. Again, it's sort of like, okay, what else? Hurry up, finish. I'm going to hit semicolon, enter, and it doesn't matter that it was on a separate line. MySQL doesn't care about how we break up our commands across lines. So this works, and you'll see I get a message, query OK, one row affected. And if I now run my show databases command, I can just use the up arrow to cycle through commands I've run. And I'll see I have a pet shop database. Okay, so simple enough. Let's just do one more. I'm going to clear my screen, create. This time I won't do it uppercase just so you can see it still works. Create database. How about a slime store? We sell slime. Let's do uppercase here, slime store. And then I'll put my semicolon there. And if I do show databases, and this time I'll do this in all caps as well, just to show you, we see slime store alongside pet shop. So we have these two empty containers now that eventually, shortly, we'll put data inside of. Now let's hop over to the workbench. I found a way to increase the font. It's kind of a pain. But what I'm going to do here is show you that first off, on this left side, I have a list of databases that the workbench knows about. And it should know about these databases I just made, but it doesn't. I have to tell it to refresh. So there's a button right here to refresh it. And now I see pet shop and slime store. Let me see if I can make this larger. Well, I just spent like 5 minutes Googling. There's no way to change the interface font size over here, so I'll just have to zoom in post-production. But as you can see now, when I refreshed, I have two new databases that are showing up, or two, they're not new, they were created over here, but their names are showing up, pet shop and slime store. And I could create a database from within here if I wanted to. Create database, I don't know, what should we call this one? How about chicken coop? Just like that. And then I hit this lightning bolt, it runs this script. And down here, I get a response that said that worked. One row affected, create database chicken coop. And if I refresh, we now see chicken coop show up here. I go back to this side. If I do the same thing, show databases, we now have chicken coop. So once again, just confirmation that we're working in the same world, just two different sort of portals into it. One is the terminal, the other is this MySQL workbench, which this is really a tiny font. I got to figure something else out. Anyway, that is how we create databases. They're empty shells. They're a husk of a database. The next thing we need to do is delete them and learn how to use them. So another thing we can do, which hopefully we don't want to do that often, is drop a database. Now this is something you actually want to be quite careful with once you have databases that have real data. We don't at the moment. Ours are completely empty, so we can play around with it. But this will remove a database entirely and all of its contents. So drop database, and then once again, you replace that with the name of a database that exists, like soap store. So let's try it. I'll do it in the command line first. Let's delete slime store. So drop database, and then I have to spell it correctly and capitalize it like that. It says okay. Let's do a select, or rather show databases. It's no longer here. If I go back to my workbench, slime store is right here. Because this is sort of out of sync, I have to refresh, and now we see it's gone. If I head over to another tool, dbgate, which I think I'm going to lean more on because you can actually read the text here compared to this. MySQL gives me no way of increasing this font size. It's kind of insane. Anyway, it's the same concept, right? I've got slime store, but if I refresh, it's gone. Okay, so I can also drop a database from within one of these. All I need to do, let's say I wanted to drop this database here, is write a script. So I'm going to click the plus sign and just run drop database pet_shop, put my semicolon in there, and then I'm going to click execute. And it finished. I'll refresh. Pet shop is gone. I refresh over here. Pet shop is gone. And if I do another show databases, pet shop once again is gone. All right, so that's how we can drop a database. Of course, you want to be careful with that. The next thing we need to do is use a database. We can create empty ones. We can delete databases, but we need to use them. And use is the actual command that we're going to use. It's uppercase use, although it doesn't have to be uppercase, but it's another one of those SQL keywords. And then a name of a database that currently exists. And this tells MySQL we want to think of it as like double clicking on this database, selecting it as what we want to be working inside of. So we can have all these different databases, but when it comes time to insert information or find information or delete information or create new tables, we have to tell MySQL where we are. So the way that we do that is use. So let's do use chicken_coop, and it tells us database changed. You selected you're working in a new database. Now, how do we know that other than seeing database changed? We have this other command, select database with parentheses. I don't use this very often, but when we're starting out, it's a great way to know that we're doing things correctly. I should see chicken coop, and I do. It says this is your current database, chicken coop. So if I were to make a new database, create database, how about T shop? I don't know why everything has to be a shop, but sure, T shop. And I run select database. I'm not using that new database. I made it, but I'm not actually working inside of it. I have to then run use tshop. And then it will tell me the database changed, but if I want to know for sure what it changed to, I select database with parentheses tshop. Now, when we're over here in Workbench or in dbgate, any of these graphical interfaces, I can write use. I can say use, let's refresh. I should see tshop. Yeah, I can say use tshop and execute this script if I wanted to. And that's fine. And then if I wanted to select database to prove that it's working, let's run the script again. It says your database is tshop. Okay, so that's fine. But there's actually an easier way to use a database. It's as simple as double clicking. So if I double click on chicken coop and I get rid of that use and I just select the database, it says you're working with chicken coop. So if I double click on tshop, I run the same thing. Now it says tshop. Same thing over in this dbgate. If I select chicken coop, or let's do tshop, and then I click the plus sign, I have a new script, and you'll see up here it says tshop. So this is using tshop. If I do select database, and I run this, we see tshop, right? If I instead went over to chicken coop, now this is still going to say tshop up there, but if I do chicken coop plus sign, and I do the same thing, select database, we'll be working in one database for a lot of the course, so it's not a big deal to change. We don't need to change. But if I run this, execute, it says chicken coop. All right, so that's how we can use a database. It's like clicking into it, selecting it, telling MySQL, this is the one database I want to be interacting with right now. Of course, we're not really interacting with them, but we are selecting them. We're using them. Next up, we're going to learn all about putting stuff in a database. So now we move on to tables. This is the real heart of SQL. Yes, we make a new database, we use a database, that's important to know, but like I said previously, we do that occasionally, but then we constantly work with tables and the data inside of tables within a given database. So we have this empty shell of a database, or maybe multiple empty shells of databases. They have nothing in them. Tables are what we need to put in those databases so that we can hold data. So you may have heard the term table before. A database is really just a bunch of tables. Now, when I say database, that only applies to a relational database. If we're talking about something like MongoDB, that's not a relational database, so it doesn't use tables. But all the SQL flavored database variants, they all consist of a bunch of tables. And tables are what hold our data. They describe the format and the shape of our data, and then they hold collections of data that follows that shape. So a more technical definition would be a table is a collection of related data held in a structured format within a database. Now that structured part is very important. Also, the fact that it's a collection of data is very important. So let's say that we were working with cats data. We're building a pet shelter or a vet database or something. This would be one way to structure my information. I could say this is what a cat looks like in our database. This is the cat's table. Every cat has a name. Every cat has a breed. Every cat has an age. I'm defining the structure. That's the first part of a table, and it will start empty. This one is not empty. And then we insert data into the table following that structure. So every cat has a name, a breed, and an age. So some basic terminology. We call the headings or the headers of each table columns. So this table has 3 columns. Now I'm visualizing it here, right, as an actual table. It's not stored this way. It's stored as some compressed thing that looks nothing like human readable code, but it will be displayed to me nicely in the same way that we see this right here printed out. It looks like a table, but again, this is just a slide diagram that I'm drawing for you. This has nothing to do with SQL on its own. Okay, so we have our columns, name, breed, and age. And then we have the rows. Those are the actual entries, the actual data in the table. So we have one row here. Blue is a Scottish fold. She's 1 year old. We have Rocket, who's a Persian cat, 3 years old, and so on. These are all rows. They are entries into this table. But the first step is to get this table empty, but with a structure. We're telling SQL, okay, here's our cat's table. It has these 3 different columns, these 3 pieces. And then once that's done, we can insert data in. So databases in general consist of lots of tables. Well, I say that, referring to a large application or even just a basic application you might work with, there's going to be lots of different entities, and almost every entity will have its own table. So there might be a users table, a friends table, a photos table, if we were making some sort of Instagram clone or something, a comments table, and all sorts of stuff for advertising and for tracking users and user behavior. You could have hundreds of different tables. So it can get a little crazy. Here are some simple-ish examples. This is some of the tables that exist in the Wikipedia SQL database. Now, this is coming from Wikipedia. It could be out of date, but we'll see things like user. Every user has a name and a password and an email and a whole bunch of other things. But then we have pages, Wikipedia pages, right? And Wikipedia revisions, because people can revise pages. There's different sites. There's logs that are written, images and files and all sorts of other things we don't have to worry about. Tags, lots of information here that is stored all in separate tables. Now, of course, most of these tables are connected or related in some ways, like pages and users, or revisions and users. Who's making the revision? Well, some user is. So there's some connection, but we're not worrying about that just yet. Here's another example. This is an old, very out-of-date attempt at modeling the table structure of a website like Facebook. We have things like basic information for a user. Sex, if they're interested in men and women. You can tell this is out of date, I guess, if they even break it down that way. Looking for friendship, relationship. All right, basic information, contact information. But then we have things like a profile, an account, a credit card, different events. We have photos. All these different entities are represented with their own tables. And again, lots of lines connecting them together. So we are not starting there. We're starting with good old cats. 3 columns, a couple of rows, but we have to learn how to make a table. And before we can create a table, we have to talk about data and the different types, the different categories of data we can work with. The next thing we have to talk about around tables are data types. So when we define the structure of a table, we're not only saying what column names we want, for example, name, breed, and age, but we also specify the types, what type of information is permitted in each column. And this is really, really important. Imagine we have our name, breed, and age for the cats table, where age is just left up to be whatever a user puts in there. So it could be a number 1, 3, or the word 10, or I am young cat. Whatever it is, there's no rules being enforced. It might make sense that it should be a number, but it doesn't say, in our example at least, that it has to be a number. that leads to a lot of problems if we try and then do stuff with our data. If we try and multiply it by 7 to get a rough approximation, converting between cat years and human years, or vice versa, human years and cat years, to get the cat age, you multiply by 7, which is actually not really correct. That's a super simplification. It's not some easy formula. I looked it up recently, but this is good enough. I want to multiply them by 7. So 1 times 7, that's easy. 3 times 7, that's easy. 10 times 7, we have a problem. The word 10 times 7. And I am young cat times 7, it's just not going to work. So we need consistency of our types. We need not just to say what this column is called, but also what content it contains, what type of information. I want to say something like name has to be text, breed has to be text, age has to be a number. So in the world of MySQL, we have a lot of different data types. It's honestly kind of overwhelming. The good news is that there's a handful you'll use a lot. But let me just show you. We have different types for numbers. You might think there's just a number type. That's not true, unfortunately. We have a type called integer or int, then we have small int, and even smaller, we have tiny int, and then medium int, and then big int, and then decimal, and then numeric, and then float, and then double, and bit. It gets just absolutely crazy if you try and master or learn the differences between all of these up front, so don't worry about it. But just know that there are a lot of different types. Same thing for string types or text types. We have char or car. I guess you should pronounce it car because it's character, but I've always said char, even if that's incorrect. Varchar, varchar, binary, var binary, blob, tiny blob, medium blob, long blob, text, tiny text, medium text, long text, enum. So these are all different categories of text information. And there's differences, that's why they exist, but a lot of the differences are very slight. So we've got numeric types, string types, and we also have date types. So date, date time, timestamp, time, and year. It's a little crazy. If you ever get confused or you have questions, the first thing you should do is head to the docs. There's a page about data types and the documentation and the reference manual. So if you want to know more about, string data types or numeric data types, click on that, and then you'll see the different categories. And then you can click to get more specific. If I want to learn more about small int, whatever that is compared to int, I can click here, and it will tell me. I can find out the rules, and we're going to dive into some of this stuff later in the course. So for now, we really don't need to worry. You should just know that there are different categories of information, different types, and there's 2 specifically that we're going to work with right now. Integer, or int for short, and varchar or varchar, which is a text or a string data type for textual information. So let's talk a bit more about int. Int or integer, you can write it either way, but int is nice and short, is a whole number, so no decimals, and it has a maximum value of this number right here, but this is a maximum signed value, meaning that we could also have negative this value, so negative or positive. You can have a larger maximum value if you set it up in such a way that you don't allow signed values. It's unsigned, but we really don't need to worry about that. I just need to put that in there to be specific, but at the end of the day, it's a whole number. And unless you're dealing with really big whole numbers, you really don't need to worry about the maximum size. So something like 12, that's a valid int. Negative 9,999, valid int. So is 0. So is 314567 or 42. Those are all integers. Now we have varchar or varchar, which is a variable length string. That's the var part. There's also just a data type called char or char that is not variable length, and we'll see that later. So when I say variable length, that means that we can store something that is this many characters. What is that? 4, 5, 6, 7, 8 characters long, or this many characters. Now this is a number, but notice it's in quotes, meaning it is treated as text, or this many characters, or a single character, or a whole sentence, 26 plus characters, way more than 26, whatever number of characters this is. It's a variable length. So varchar is really commonly used because a lot of the time our textual information does vary in length. Think of people's usernames. Somebody might have the username Colt. That's nice. They were there early. It's 4 characters. But somebody else might have to have, Colt 4, 5, 6, 7, and so on. It's more characters. So that's varchar and int, the two basic data types we're going to start with. Now, the next thing you need to know is that when we create a table and we assign the data types, with varchar, we can actually specify a maximum number of characters allowed. So with varchar or varchar, I can say maximum of 100 characters for name, and let's say for breed, the same thing. Maybe I want it smaller. It's hard to say. Is there going to be a cat name that's 100 characters or more? Maybe, maybe not. But this allows me to specify a maximum size. So it can still vary between 0 and 100 characters, but the maximum is 100 characters that we'll store in this column for each row. And then for int, we'll just say int. And this just says an integer of any size, assuming it fits within those bounds that I showed you, that really large number. We can go anywhere up to that size. So for age, it's going to be fine. Although something we might want to consider is age best stored as a whole number? What about fractions or decimals? Because right now, that is not an option if we're using integer. But that's for another section coming up. So I'm going to stop here because it's a long video. We covered a lot. The basic concept is that there are all these different data types in the world of MySQL, 10 plus number data types and 10 plus string or text data types, not to mention dates and times, and even other things like spatial data types. These are all different types that we can assign to columns in a table. And then the database, MySQL, will enforce those types. So with varchar, that's the one we're focusing on for text for now, it represents or it stores text of variable length up to whatever size we specify in those parens. And then int will store whole numbers. Okay, next up, we've got a quick little activity. Okay, we have done a lot of groundwork talking about tables. Let's actually see the syntax to create a new table. So to create a new table, we specify a table name, but we also specify all the column names and their corresponding data types. So we run create table, that's always create table, and then the name of our table, and then parentheses, and then column name, data type. So that could look like this. Create table cats. Every cat has a name column that is text. It's a varchar 100 length maximum. And age is an integer. Those are the only two types we've covered, so we're going to use those two types. Now, as far as formatting, it doesn't have to go on separate lines like I have it here. It's just a nightmare to show you on slides if it's one massive line of text. But remember that MySQL doesn't care about new lines or anything. Well, it cares about the characters we type, and it cares about spaces between things. But it doesn't care if I hit return and I have new lines here. And that can make it a lot easier to enter your information. So we also need to separate our different columns that we are declaring with commas. And then, of course, we terminate the whole statement with a semicolon. So let me show it first in the command line, or in the MySQL client here. What database am I in? T-shop. Okay, so let's show databases. Let's make a new database. How about that? Create database. Let's call this one Pet Shop. Okay, and then use it. Okay. And now what I'm going to do is create my first table. Let's just do what we have on the slides here, or maybe slightly tweak it, but we'll create a table for cats. It's a pet shop, which I feel bad. It should be a shelter really, but I don't want to change it now. So create table. Once again, that doesn't have to be capitalized, but it helps it stand out. I'm going to call this cats, and then open my parentheses here, or on the next line. It really doesn't matter. I'll just do it right there. And then my first row, or my first column rather, is going to be called name, which is a varchar. And do we need a limit of 100 characters? Maybe a cat's name has to be 50 characters or smaller. Sure. And then a comma. And then I'll just hit enter again. And on this line, I will do age is an int. So let's just leave it at that. And then close my parenthesis and add my semicolon. And it looks like it worked. How do we know? Well, there's a couple of ways. In this video, the one that I'll show you is if we just go over to one of our tools like dbgates or MySQL Workbench, if I refresh the connection, we see Pet Shop. And within Pet Shop, we should see, hello, there we go, the cats table exists. Same thing over here. If I refresh my view here, we see there's a pet shop database. It has a table called cats, and there it is. That's cats. Now that's kind of a janky way of verifying that it worked, but in the next video, I'll show you some other commands that we can run from the command line. Now we can also make cats or any other table. Let's make a dogs table from within one of our SQL graphical interfaces. So it's the same process. You make sure you're using the correct database, and then let's close this. I will double click on the pet shop, click my plus sign, and write my script. That will do something like create table dogs. Let's just do dogs this time. And it's going to be the same sort of pattern. I'll indent if that makes it a little nicer to look at. So name will be, once again, a varchar. Let's do 50 characters. Age, let's do breed for dogs. Breed will be a varchar of 50 characters as well. And age is an integer. You can write it out like that or just do int. And then I have my semicolon. Okay, and then if I click execute here, that should have inserted a new table for me into Pet Shop. And that table, if I refresh down here, is called dogs. We see it over there. Same thing in Workbench, MySQL Workbench. It's really hard to see over here with that tiny little text, but there is now a dogs table. Okay, so that's the basic syntax. That pattern you'll see all over the place. You use it all the time, every time you need to make a table. Create table. The name of the table. You want to come up with a name that makes sense, of course, and usually it's pluralized, but there's no rule that it has to be. And then parentheses, and then our column names with their corresponding data types, separate them by a space, and then separate each column using a comma. Terminate it with a semicolon. So we'll get a lot of practice creating tables, but that's the basics. Next, I'm going to show a couple of quick utility commands we can use to inspect our tables. So if we created a table, and we're not using one of these graphical tools, how do we know from within MySQL, from within the command line, that it worked? Well, the first thing we can do is just look at the tables. What tables exist using the show tables command. So this is going to show the tables from our current database. And remember, I had to use a database. I'm connected. I'm inside of one database, which is Pet Shop. And there's two tables in there. But if I switch to some other database, like I think I have a T shop, and if I try show tables, there's nothing here. So we have these different silos of information, silos of tables. That's the whole point of separate databases. So let me go back to Pet Shop. All right. And then show tables, we've got cats and dogs. But what if I want to know more about the tables? Are they correctly formed? What are the column names? I can use a command called show columns from, and then the name of a table. So show columns from cats. And there we go. There's some extra information over here we're going to learn about very soon. Null and key and default. But you'll see we have the name of the field. It's just called field. So name or age, and then their type. Varchar 50, integer. Same thing if I do show columns from dogs. Name is varchar 50, breed is varchar 50, age is an integer. Okay, now there's actually another even shorter version, which is DESC for describe table name. So I believe you can actually just do describe cats, but that's way too long for all of us, of course, so we can do desc or describe DESC, and that's going to give us the same output we've already seen. Now, if you are trying to work mostly within one of these graphical tools, we don't have to run those commands. I mean, I can. Here I am in Workbench. If I make sure that I'm working inside of the Pet Shop database, I can then do something like describe dogs and then execute that. And we see our result here. It says name is varchar 50, breed is varchar 50, age is varchar 50. Age is an integer rather. I can do that, but I have an easier way. If I just look at one of the tables, like cats right here, way in this corner, it's hard to read. And once again, this app doesn't let me zoom in. You'll see it's showing me the columns. Name is varchar 50, age is an integer. So I don't really have to run a command to get that information like I do from the command line. Same thing over here in dbgate. If I look at the tables for Pet Shop, so whatever database I have selected, it will show me the structure. So this is an empty database, there's no tables, but Pet Shop has two. Let's look at dogs. Look at how nice that is. It says name is varchar 50, breed is varchar 50, age is int. It's showing me the columns. I don't have to do anything. But I could also ask for those columns if I wanted to. By the way, right here, I just commented SQL out, in and out, meaning it's inactive. It's still here, but this code won't do anything if I run the script. So that's a SQL comment. I'll have a separate video on that just to make it clear. But 2 dashes will make any line of SQL null, or basically do nothing. It comments it out. It preserves it so we still have a record of it. And I can toggle that on and off on my Mac using command /. But if I run this right now, let me shut this down a bit, execute, well, nothing happens because there was no SQL here. In the eyes of MySQL, this was empty. So what I was going to show though is I can describe cats, for example, but it's kind of silly. If I'm using one of these graphical user interfaces, if I open up my results pane, here it is, name, varchar 50, age, int, but I could see that easily if I just look at cats visually. Okay, so that's a long-winded way of saying there's many ways to check your work, to see if our table was created successfully, to see what the columns and data types are. You can do this long version, or just nice describe. Or even nicer, if you're using a graphical interface, don't do any commands and just look at the results or the table view that it shows you. The next thing we need to know about tables is how to get rid of them. How do we delete a table? Well, we use a drop table command. Remember there was drop database, that drops an entire database. Well, drop table just drops a single table, but you still need to be very careful with it because if your table has a lot of information in it, you can lose all of that. It doesn't stop you. It doesn't ask, are you sure? It's just going to drop that table. So our tables right now are empty, right? If we do show tables, both of them are empty. That's not proof that they're empty, but we know they're empty. If I want to drop one of them, let's drop cats, drop table, cats, semicolon. And that's it. It didn't give me a heads up or anything. It's just gone. If I do show tables, now we only have dogs. If I refresh the table view over here in one of my graphical user interfaces, we only see dogs. Same thing here. If I refresh, we only see dogs inside of Pet Shop. If you can see that at all, it's so tiny. Now, another way of deleting a table from within one of these user interfaces is to right-click. This is in dbGate. Right-click on the table. I can click drop table, and then it's going to create this little bit of code for me, and then I can run that code if I want to, but you'll notice it says drop table inside of there. I assume on Workbench we can do something very similar. Right there, drop table, if I want to drop the dog's table. This will ask me to review the SQL or just click drop now. I'll just click drop now, and now that table is gone. Now, I hope you're not dropping lots of tables all the time, but if you do drop a table, I always say, well, I don't always say, but I would always recommend that you take a moment to think about what's in that table. Maybe once we learn how to view the contents, run that first, and then drop a table. But that's my fault for showing you how to drop a table before we can even check what's in them. But for now, that's all you need to know. Drop a table using drop space table and the table name, and it is gone, really gone. It's not coming back. It's time for you to practice creating and dropping your own table. This will be quick. Here we are. Instructions. I'd like you to create a pastries table called pastries, and it has 2 columns, a name and a quantity. Name should be the name of a pastry, like, what's a pastry? A muffin, croissant, and then also the quantity, which should be a number, an integer. So create that and then inspect it. Make sure those columns exist. I said in the CLI, in the command line, if you're not using the command line, then just inspect it using the Workbench or some other tool. Make sure those columns and types are correct, and then delete the table. So pause it, try this on your own. Hopefully it just takes you a minute or two. And here is a solution. So I'm going to run a create table. I'll just do it in my database I'm currently using because I'm going to drop the table immediately after. So create table pastries. And then I need parentheses somewhere. I'll do it on one line. Let's see if it fits. So pastries is going to have name, which is supposed to be text up to 50 characters. Varchar 50. And then we need to have quantity, which is an integer. Quantity int just like that. I'm missing a closing paren. It's already looking bad on a single line. It'd be better to put some returns in there, but this should work, right? Create table pastries, opening paren, closing paren. Name is a varchar 50, up to 50 characters. Quantity is an integer. And it looks like it worked. How do we know? First step, we could do show tables. There it is, pastries. What else can we do? We can describe pastries. And there we are. Name is a varchar 50, quantity is an integer. And then of course we can use one of our tools and refresh the tables, and we should see pastries is here, name, varchar 50, quantity, integer. Same thing in the workbench, refresh. I'm not going to keep doing this throughout the whole course, showing you every option, but it's still early on. So inside of tables, we see pastries, and down here it says name, varchar 50, quantity, int. And then the last thing we'll do is delete the table. So I'm going to do that from the command line, drop table, pastries. And we know it worked. If I try and describe that table, we get an error. If I do show tables, it's empty. If I refresh over here, it's gone. Okay, so that's our first little basic exercise, creating a table, inspecting it, and dropping it. Next up, I'd like to show you MySQL Comments. Now this is a piece of syntax that technically you could use if you were working in the command line, but it doesn't really have any benefit. Most of the time you'll see this is in a file. So when I say comment, this is a concept that is pretty ubiquitous across all programming languages. The idea is that I can have some notes in my code. I can have pieces of code that I don't actually have execute without deleting from my file. An example would be, let's say I have some piece of syntax like show tables. Obviously that is MySQL, we know that, it works. But then I want to annotate it up top and say, to list all tables in DB. Well, if I tried to run this file, this is not valid SQL code. We're going to have a bad time. I could run it in the terminal and you see I get an error. I try running it over here, I'll also get an error. It might be hard to show you. There it is, see that red right there? That is an error. So to avoid this, if I want to have a note or some piece of code that I turn off, I can use 2 dashes and then a space. I do have to have a space afterwards. You'll see that the editor changes color here, or I guess it doesn't change color, does it? It changes the font weight. It's not bolded anymore like it is here. So now if I ran this, we don't get an error. It actually just runs this code, and this is completely ignored, but it's still there, right? It's not deleted, it's just ignored. Same thing if I did it for this line. I don't want this code to run right now, but I want some other stuff to run. Well, I can leave it in there with 2 dashes, assuming that it makes sense to leave it in there. So you can use this yourself to make notes in your SQL files within the workbench. Technically you can do it over here in the command line. I can do like show tables. If I put those 2 dashes in front, it doesn't run. I do the same line without those 2 dashes and it does run. But most of the time you're going to do it in a file. You'll see it in some of my solution code. One common situation it might come up is if I have some code, which we haven't seen this is later in the course, but some code from the future, and I want to leave it in here, but I want to do some other stuff down here. I don't want to delete it, but I don't want it to run again because this is making a table. I don't want to be making a table over and over. I can highlight this, and instead of having to do a hyphen here and then another one here, or a comment rather, I can highlight it in the workbench and then use the shortcut Command / on a Mac. I believe it's Control / on a PC. And then I can undo that again, toggling it with this same shortcut. So that can be nice, and you'll see me do that at some points in the course, just so that I can have some code, have a record of it, but not have it run every time I run this file. Okay, that is it for comments. 2 dashes. I think they're dashes. Are they hyphens? I think a hyphen is longer, right? I don't know. Anyway, those 2 characters and then a space, don't forget the space, will make SQL ignore your code.